numeric column, I can calculate the sum of each and every number. Same for this column and null. So any column that is numerical, it will have this summation sign, letting you know that it's a numerical column and the sum can be what's calculated. So Power BI is automatically doing a what? Is automatically doing a bivariate selection. So in this first canvas here, what is the first thing? We are saying the sum of range in kilometers by segment. So there are different segments in this data set, segments from A, B, C, D, E, F, N, A, S, blah. So for each of these different segments, these are the what? These are the sum of the range in kilometer. So the segment C, that's electric vehicles that fall into segment C, they have the highest what range that they can go for before they get before their battery gets exhausted. Then the next in line is the what? Segment D. So this is what this visualization here is telling us. So you can see it also gives us a brief summary that at 9,890 kilometer, C has the highest sum of what? Range in kilometer, and it is what? 918.56% than S, which is the lowest sum. So C accounted for 28.31% of the sum of range. So you can see that this has automatically given us what? A brief summary of what is happening in this bivariate what? This bivariate distribution. It also says here that across all 8 segments, the sum of range, that means the sum of range, the range from what? 970 to what? 990 to 99,880. Sorry. So 970 to 9,800 and what? And 80. So across all these segments, this is the different ranges that we have. If you come to this other one, it is also another what? It is also another stuff. So this one now is taking another column. So this one was for what? Range and segment. This one is now by what? Efficiency by segment. So you can see that C has the highest range and C also has the highest efficiency. So electric vehicles that fall into the range of C had the highest what? Efficiency. Electric vehicles that also fall into the range of C had the highest what? Acceleration. So we can see that once an electric vehicle fall into the segment of C, it is enough for us to determine that this electric vehicle is going to be a what? A high range, high acceleration, and high efficient what? Electric vehicle. So if we now say that sum of range by body style, this was just one that was automatically done. You see that for the range, here was range by segment. This is range by body style. You can see that the SUV had the highest range. The body style SUV had the highest range. After body style SUV, that's hatchback, then sedan and stuff like that. So these were the ones that were what? Automatically generated. Based on this automatically generated data, you have seen some insights that are what? That have been okay. You are raising up your hand, HP. So you wanted to say something.
I have a question concerning the
Okay.
automatic summation of the numeric columns. Is there a
Okay.
way to undo the automatic summation such that it brings the values as they are instead of summing them up?
Instead of summing them up. All right. So for the Power BI, it's this summation doesn't mean that it is this summation doesn't imply that it is automatically summing it up. But if to just to visualize that, if we uncheck all of this, you can see that because they are sum, if we check all of these options exactly, so you can see that on clicking on the left click option here, it is showing us a don't summarize value. So if we click on this don't summarize, you see that the sum has been what? The sum have been removed, and then now we are saying what? Different values for different sums. So now we are saying values of 400, 500 and stuff like that. So but as you can see, the ranges of values are quite large. So it is still going to try and bin these values because they are numbers, they are numerical. So we can't off the top of our head just say that it can be 140.1, another can be 140.2, 140.3, and you get. So what it does is it's going to try to automatically bin these numbers into like at least, let's say, categories of 10, categories of 100 and 500 depending, because trying to showcase all of these numbers might become hectic and tedious for the system. So but yes, you can undo the sum. I hope you saw how I undid the sum. Was that clear enough?
Yes, you right click and select don't summarize.
Sorry, I did not get that.
You selected the don't summarize by right
Yeah, the
clicking.
don't summarize.
Yeah.
Exactly. So when you click on that, it will undo the sum, and then you can see the values as they are.
Thank you.
Yeah, you're welcome. Okay, so please, if you want to ask a question, you can just probably unmute your mic. Why is that? Because I'm like not on the tab where I can see a hand that is raised or something. So I have to like switch between tabs, and the only time I switch between tabs is when I want to come and see if there are more people in the waiting room. So because I'm using the web version and not the Zoom app. So you can just like unmute your mic, just say you have a question, and I will attend to you immediately. Okay, so continuing with that, so let me just so let me undo all of this check. So as you can see, once I undid all of this check here, this is an empty what? An empty report. So immediately you start selecting different things, you can start selecting the report. But one thing I want us to notice is that with the Power BI, it's it tries as much as possible to give reports, but it doesn't give reports that are that combine two categorical columns. If you understand what I'm trying to say, let's say for example, this is the body style. Now let us look at the correlation between body style and brand. Even though I selected both body style and brand, you will see that all of this here, this for example, this first canvas here is what the range in kilometer by body style. This is a numeric to categorical. This is efficiency to body style. This is a numeric to categorical. Same for this, same for this, and this is equal to equal of price to the brand and stuff like that. So for all of the wonderful automatic generation that Power BI can give to us, it doesn't actually gives a de facto categorical to categorical what? Categorical to categorical combination. So it has to be done manually by using this edit button. So when you choose the edit mode, you lose access to your data pane. You want to continue, you click on yes. So you can now start changing the kind of visualizations that you want. So format page, page information, blah blah blah. Okay, what kind of data do you want to include there? What to be on the x-axis, what to be on the y-axis, and all of this kind of stuff. That is when you'll be able to make custom visualizations that will be able to what showcase both the categorical and the numerical. So this was when I chose this visualization. For example, this is a scatter plot, and you can see that this scatter plot shows this. So what I can try to do for this scatter plot is I can try to okay cross report. So I want to try scatter plot is basically used for so I need to drag. Okay, so if I want to drag, let me see if I can. So for this table, so let me see, and let me get the price. Okay, so this is the sum. So I don't want the sum, so let me say don't summarize. So I'm trying to get a scatter plot between the price and the range. Okay, so this is doing it for the sum, so I don't want the sum to be summarized. And I'm trying to click on the do summarize option, but unfortunately it's not coming up here. Let me see if I can do this first. Okay, let me select this. Okay, and save this for example. So on this visual, no, this is not what I want. Okay, so this is the table. Expand all. So let me undo this first. Undo this also, and let me see. But this is the body style. So unfortunately, this is not giving me as expected as I want. But we'll do a scatter plot with Python. I think as I mentioned this last time, this is not my specialty. I do most of my stuff in Python. So just wanted to showcase this to you guys. But we should be able to undo all of this. Let me see. Let me see. Let me see. Filters, visualization. So So for this visualization, so this is another visualization. So all of these visualizations are coming up, but I'm unable to drag the data as it is rather than it being a sum. So I would have loved if this had, let me call it a visual level filters. Okay. So if I don't get this in real time, probably just got it. Probably just leave this and then move on to another stuff. But this is the multi-row card. So let me drag this here. So let me see if I can change the data that is in there. Because what I actually want to change is the data. The visualization is as I expect it, but I want to change the nature of the data that is in there. And this should have given me the option to unsummarize this data set, but unfortunately it's not coming through. So let me delete this. Let me delete this and come back to the report. Let me see if I can edit. Let me save this. Nah. Sample and then save. So the report is saving. So once it's done saving, I'll try again to see if I can try to showcase the scatter plot. But basically, that's the functionality and power that Power BI gives onto users. So it's number one, it helps to automatically generate some of these reports from these visualizations. And once these visualizations are automatically generated, you can immediately see insights from that data. So another thing you can do is um, you can start making visualizations, and all of the visualizations can be what can be exported. What do I mean by exported? So you can just click on export and share this as a PowerPoint. So when you share this as a PowerPoint, all of this dashboard will just be what bundled into a PowerPoint presentation, and that can be shared to anyone that you want to share it to. Okay, new table. Let me see if I can create a new page. So let me create a new page. So let me, no, definitely not this. So the scatter plots. Okay. Filters on visual, more options, trigger option, blah blah. So let me just come here and see if the option to unsummarize is here. Let me take the seats and this stuff. Okay, so much. So I want to edit this value. I don't know why. Data model. Let me see. Uh, 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 uh. Okay, I'm currently in another tab. I'm trying to see if I will see the unsummarize function there, but in that other tab also the option was not there. So I'm still shocked because when we created a new report, we were able to like unsummarize that and see all of the values. So I don't know why. So let me see if I can add the data fields. The x-axis. Oh, so I think I eventually found it. So this is the don't summarize for the x, the seat, and the y-axis also. This is the don't summarize. So now this is the scatter plot I was trying to show you. So the scatter plot is the scatter plot. Oh, I don't need this. So as I was saying, the scatter plot is a visualization that, let me just zoom in, a visualization that helps to show the relationship between two categorical values. So as we can see for the seats range between 2, 4, 6, and 8. So that means cars, electric vehicles that are created mostly have what seats that are what either two, they have two seater, four seaters, six seater, and the max we have seen is eight seater. But what we can see is that as the um as the number of seats increase, we begin to see like an approximate, okay, this is the top speed. I wanted to use the price, but this is the top speed, but this is basically the same thing. You can see that when the seats, for this is actually not each data point, but it is just like a high level overview of what each data point is carrying. So we can see that for seats that are between 4 and 6, that's five seaters, the prices are what are evenly distributed among the five seaters. But for the six seaters, we have four seaters that are way more, sorry, that have higher top speed, uh, that have higher speed than the what than the six seaters. So with this we can see that there's almost a relationship where the higher you go, the lesser your speed tends to be. That is what this scatter plot is trying to show us here. Because as you can see, when we were at 2, okay, at 2, we have a very low speed accepted. But when we got to 4, we saw speeds that got up to what 400. At 5, we were seeing speed above what the 200 mark, above the 250, almost bordering around 300. But immediately we got to 6, see the kind of seats we had. And when we got to 7, see the kind of seats we had. The highest, the number of seats, the top speed we had at a 7-seater car is not up to the top speed we had at when we had 5-seater, and it's not even nearly close enough. And this might be an outlier. So there are things in data sets called outlier that might be dragging your data set, but on the first look, this is what we have. So what we can now do is we can now check all the different outliers. We can see if this 400 is actually an outlier and it is not popular. So if it's an outlier, then we can remove this. Once we remove it, we'll then plot again the scatter plots, and you'll see that your visualization, the conclusion that you had before, has changed due to the fact that you have removed the outlier from that data set. So if I want to change this for this, so I just have to like change this instead of seats. So I can change this to price. So let me remove this field.
Can I
And
ask a question, sir?
yes, you can.
Is that you mentioned removing outliers there. How can we do it when we are not using Python command in dealing with Power BI?
In Power BI, as I've said previously, I'm not an expert with Power BI. I know it's possible to be done, but I don't think I'll be able to do it here. But if we just probably, it's just probably, let me share another tab and just try, because everything that we are doing can be researched. So let me see, removing outliers in
BI.
Power BI. So you can see it. There will be like I don't really like videos and stuff. But if we go, okay, another tab has been opened. If you go into another tab, is there an easy way to remove outlier? So it has been solved. Let's go to the solution to see what they said. So in the solution, so let me see this exactly in some question revenue. So I think you want, so I think in Power BI also there are places where you can begin to what write code, because it is known that doing everything visually might not be possible. So I think in Power BI, what they expect you to do is you are going to, because based on what got it to work, I'm not sure what I was doing, but I started from scratch, daily revenue, blah blah blah. But from what I'm seeing, this year is a Excel sheet, an Excel formula. This year, this code that was accepted as the solution, that's reason as in some content. This was what was accepted as the solution. And since this was what was accepted as the solution, this means that they expect you that in the Excel sheets, you know that when we're copying in some, when we're starting this visualization, we copy the Excel sheet into this page to generate this visualization. So they expect you to write an Excel formula that will remove those outliers and then bring the new Excel sheet that does not contain that outlier and then bring it back into this board for it to be visualized. So I don't think you can like use but what you can do now is you can see that the top speed is around what the outlier for the top speed is around what 400. Yeah. Okay, so let me do something now. Let me say I want to create a new report or something. if I have that. So would you like to, don't save, no need to save. So let me say I want to create a new report. So let me pick and let me again copy all of this code. Yes. So what I will now try to do now, can I do Control F? Let me try to look for 400. If Control F will work. Exactly. So this is for the range. Um, where else is there 400? So this is for the range. I want to see if there's anything like 400 where
450 there.
somewhere. Sorry?
450 there. When you flip down now.
Okay, when I went down. So let me say 450. So this is also the range, but I'm looking for something in the, I think we were doing, the outlier we're doing was the top speed. So I'm looking for something in the top speed. In the top speed. So this is 400 for range. So let's just go through all of the top speed. So you can see this is 410
Yes, sir. That should be
for the
the
top
value.
speed. I hope you guys can see this value that I'm
Yes,
clicking.
yes.
Exactly. So what I'll just try to
That
do is
is
let me try to remove this column. Is there a way to just exactly delete this row? So I've deleted that row that signified around 400. Yes. So now let me create a new report based on this data that removed that
how about if
410.
you have 400 alone, sir? Just the cell. I don't know. I'm just asking.
Sorry.
I'm asking what if we just expunge that 400 from the cell alone without necessarily deleting the entire row?
If you expand it from that cell, you are creating a non value, because if you
Okay.
remove that cell, then that cell will be empty for that row. I don't know if you get what I'm trying to say.
I
So
get a
if
point.
that
I get a point.
exactly, so it's better remove the rule, or you can just calculate the average of all of the data in the top speed, in the top speed. So after calculating the average, then you replace the 410 with the what, with the average. So let me create a new page. Let me edit this. Okay, so I click on edit. So let me create a new page, and then let us pick what scatter plot again. So if this is a scatter plot, then the data field for the data is selected. We selected the seats. Okay, and we also selected the what, the range. Was it the range or the top speed? I think it was the top speed. So coming here, I'll change this to don't summarize. I'll also change this here to don't summarize. So now if we look at this, you can see now that we are not seeing any seats that gets up to around what, 400 again. Now the
And the
data
scale
set is right, the scale has even changed. You can see now. So now the previous conclusion that we made, that as seats get higher, the top speed increases or something, that conclusion will be thrown out of the window now, because now that the scale has been changed and that outlier has been removed, you can see that there's really no correlation between the seats and the what, and the top speed. At 4 we see top speed of around 250. At 6 or 5, top speed of around 250. At 7, they almost get up to 250 also. So there's nothing in this scatter plot that's trying to tell us that as the seats are increasing, the top speed is either what, increasing or decreasing. So we have been able to see that okay, that outlier was able to change the scale of the visualization. So that's why after making your initial visualizations, it is always very good to make sure that even before you make your initial visualizations, you check your data set and remove anything called an outlier. So when you remove things called outliers, then you'll be able to ensure that okay, even if you don't remove them, or if removing the outliers, if the outliers are too much, then you can just, if but at least there's a range for you to determine that it's outlier. Let's say you have a data set that has 1,000 points, and those 2 points are having that excessively high value, then you can say that okay, these are outliers. But out of a data set of 1,000 points, you are seeing like 25 with that excessively high value, then I don't think they are meant to be called outliers. So you have to check the balance and the scale before you deal them, and you can either remove them or replace them with what we call, we can replace them with either the mean or the average, or whatever value you feel will be better to replace them. We can even replace them with the second max value, since they are higher, then we can use the second max value to replace them. So we can use the second max value to replace them. So we can use the second max value to replace them.
I don't know if you can hear me, sir. Am I the only one?
Oh, sorry for that. Can you hear me now?
Yes, sir.
Yes. So as I was saying, so you can just there are different ways to deal with outliers, and the best way depends on the nature of the data set that you are working with.
Okay, thank you, sir. Please, I have another question, sir.
Yeah. All right. No problem.
In the early part of our documents, our reading materials, were directed to a Tableau page. Tableau.
Tableau.
So, yes, I
Yes,
want to.
that's another type of. It's something like Power BI, another alternative to Power BI.
So I was actually
Okay.
getting it. Maybe we're going to
Oh,
stop
I
like
see.
that.
I see. This is our last live coding session, so I don't think. But I'll probably try to get resources. But Tableau is not free. I don't think Tableau is free. Between Power BI and okay, let's just check that. We can just check that in this live coding session. So,
We I downloaded it.
um, you have downloaded it already.
I can't interact with it.
Sorry, I did not hear that.
Yes, I downloaded it already, but I couldn't interact with it. It's just,
Okay,
I
it's
mean,
just no problem. Maybe I'll try to get a better material on that. But from the little experience I have with Tableau, it is basically almost the same thing as Power BI. They just expect you to give them a tabular data, and once you give them that tabular data, they're also able to automatically help you generate reports, just like Power BI is doing. So that's basically what Tableau. So they are called no-code tools. Am I still live like this? Can you guys hear
yes,
me?
yes, sir.
Okay, but okay, my screen stopped sharing. That's why. So I thought I was
One
disconnected.
second.
Can you see anything on my screen?
No, sir.
Okay, let me just do that again. So as I was saying, so these there are no code tools that help with visualization. So all of these no code tools, they all have their method of doing things. So what I'll just try to do is I'll probably try to get better materials that can explain what how Tableau does it. But basically Tableau follows this same process where you provide it with a tabular data, and that tabular data is used to automatically generate different reports and visualizations.
Thank you, sir.
Yeah, all right, no problem. So this has taking some of our time. So, but that's basically it. So, as you can see now, I've been able to showcase something that deals with what two numbers, unlike in the original report that this that is automatically generated for us in Power BI. So, what Power BI does is it always takes one categorical and one numerical, and then works on each of them. So, um, is there any other visualization that we can try to do? Let me see if I can try to do a pie chart visualization. Yeah, so this might probably be the last one. So let me just drag this here. So after you select the visualization you want to do, then you come here to add the values. So it will tell you what you need. Okay, so these values now, what does it mean? So it needs like, let us see, it's better to do this for a categorical kind of stuff. So let us see. I think we spoke about the power trend the last time. So let us see about the plug type. So the plug type, okay, that's not for the legend though. The values for the plug type. Okay, let me select plug type again. I want the plug type to be for the values. Okay. So I think whatever I select first. So let me just pick one more. Details, values, and nothing is coming up. Okay, let me remove this and then take plug type again. Oh, I see. So they have to be like what has to be in the values has to be numerical in nature. So I cannot say I want to do so if I pick, let me see if I pick something like seat for example for the values. So now this is working as expected. So if we go into this now, what this is trying to tell us that for different kind of plug type, these are the different type of seats that this kind of plug type are having. So let me try to remove this and see if this visualization will be better and see if we can try to understand it. So for this type of seats, 4, 3, and 6 and 41. Let me see sum of seats. Let me remove the sum or the maximum. Okay, so this is a better visualization. So we can see that for plug type 1, the maximum type of seat for plug type 1 is 7. The maximum type of seats that we have for plug type 2 is 5 seats. The maximum number of seats that we have for plug type 2 is 4 seats. And the maximum number of seats that we have for here is what? Is 2 seats. So this is another kind of visualization. So you just have to be able to like come up in all fairness, this is my very first like interaction with Power BI, because I don't use it because I believe in writing the codes and stuff like that. But and I'm not usually the one handling the data storytelling, so I'm just on hand to fill in. So that's just for to do justice to what the course content is saying. That's why I just try to like say, okay, let's try and practicalize with this. And at least for my first trial, this is not a bad thing to at least to be able to come up with. So for people that are going to major in data storytelling, you just need to be able to look for ways that, okay, what are the kind of questions that can be answered with these data sets. So to just, okay, for our last demonstration is let us go back to our code there. That's for Power BI. And let's see if we can, one of the questions that we answered, what was the question? Let's see if we can recreate this. This question was to answer the highest efficiency in the data set based on the what model. This was to answer the highest efficiency based on the model. And this is even very simple based on what even is part of what these guys here have been trying to showcase to us. So if we come here now and just say that based on the model, let us see the highest what efficiency based on the model. So you can see that as expected, the models are much. So it's the data set, the how do I put it? This visualization is not looking as what as beautiful as all of this. So what we can just try to do is let's see if we can increase the scale of these data sets, or let me just come to a new page and select data. So this is a stacked column, a clustered bar, a stacked bar, blah blah blah. I want just a normal bar chart is what I want. I want a normal bar chart. Oh. Don't they have normal bar chart here? Okay, let me pick this one for
Sorry,
example.
sir, your screen is not moving. It just
Oh, sorry. Can you see the screen now?
yes.
All right, thank you. So just to recreate that, so what we're trying to recreate is that for each model, we want to see the what? We want to see the highest efficiency. So we want to see the model that has the highest efficiency. So on our y-axis, let us see if we want to create this if we want to create an exact replica of this. On our x-axis, sorry, y-axis, we have the models, and on the x-axis we have the what? The efficiency. So let us come back to visualization, and on our y-axis we are going to select the what? The models, and on the x-axis we are going to select the what? The sum of the efficiency. So you can see that this is basically what we want. This is basically what we drew out in that other side. So all I just have to do is to just drag this a bit, and the scale has changed. So as you can see now, for the efficiency, based on this data set, for the fact that we have removed one row, if you can remember, you remember clearly that to remove that data set, to remove that point that had 400, the scale of the data has changed. So when we visualized this yesterday, the one with the highest efficiency was the EQV long 300 with this value around 250 and something. But if we come here now on this data set, we can see that now the ISOL has taken the highest efficiency point with 350, and the EQV 300 long is now what? Coming second place with a sum of efficiency of 273. Why? Because this is because we have changed the what? If I come back here, this was our yesterday visualization. You can see that or was this for efficiency? Let me confirm. Yes, this is for efficiency. I can see that for efficiency, it was the EV long 300 with around something that got the highest. So now that we have removed this, so to confirm if this visualization are actually telling us the same thing, so let us go back. Let me see. Do I still have my, okay? Yes, I still have my data here. So what I'll just do now is I'll just recreate this same thing. The first thing I'll do is, so this is our efficiency, yes. So what I'll do is I'll first create a data set copy. So sorry, df underscore c2, and in ds underscore c2, what I want to do first is, okay, let me just run this first. So let me get the df underscore c, where the, what did we remove? I think what we removed was the top speed. Exactly. Where the top speed. Oh, okay. So I have to create is, it has to be from the df. So df, the top speed. What's the top speed? Exactly. The top speed is equals to 410. So if we do this, we get a
Sorry,
lot
please,
of traffic.
what are we trying to achieve, sir? I'm sorry. What are we trying to achieve, sir?
What we are trying to achieve is, if you see that for this visualization yesterday, when we checked the highest efficiency in the data set, the EQV 300 long model had the highest efficiency. You can see that in this visualization when we sorted the values. This was the model with the highest efficiency in the data set. But now in Power BI, we have, we are now summing what the different efficiencies and the model, and the EQV long 300 is now coming what second place. I hope you can see this. So I want to show that the reason why it is coming second place here is because we have removed the what, the outlier. Because remember that for this visualization here now, we removed that row that corresponded to what 410 for what, for top speed. So just by removing that one row that corresponded to 410 for top speed, the highest efficient, the vehicle with the efficient, with the highest efficiency has changed from EQV to ESOL. So I want to now use Python to now remove this efficiency. Sorry, I want to remove that 410 outlier that we removed. I want to remove it in Python and now plot
Okay.
out the efficiency again in Python and see if it will be the same as what Power BI is giving us. Do you understand me now? All right, so that's what I'm trying to showcase here. So equals, okay, I have to change this. I have to add this here, and I need to say df and add this here. Okay, so this should work now. So you can see that this is the Tesla Roadster, Abi. This is what's index. That's index. Okay, so this is index 51. So what I want to do now is I'll create a new something, df underscore c2, and this will be equal to what, df underscore c. Oh, okay, let me just do this first. Let me do this because this would have sorted it, so I don't want that to be sorted first. So for the df underscore c now, I now want to get dot location minus index 51. Let me try this. So if I do this now and check df underscore c2, so this is getting only the Roadster. I see. But what I want to do is I want to remove the index is not equals to. So this should work because what this is saying here, what this is saying here. Okay, let me just check DFC first. Because I'm trying to say that what this symbol here tells Python is that, okay, give me everything apart from this, what, apart from this particular index. or apart from this particular number, if you put it that way. So that's what I'm trying to do here. So I want to just select every other thing apart from what corresponds to index what? Index 51. So you see, you can see this is minus 51. So the iLog should work, but I don't know why it's not giving me the iLog. Let me see DFC2 again. It's giving me just something. Okay, to not waste much of our time, let me just ensure that DFC is what I expect it to be. So since this is DFC, so what I need to look for in DFC now is, let me rerun this. So this is the brand. So in the DFC, I just have to get the DFC where the brand. Oh, okay. Yes, that was correct. But then that should work now. But as you can see, the model is the Roadster for this brand. So um when I'm doing this and I tell you to print out the DF underscore C2, so what it is selecting is just that Roadster. But I'm trying to tell you that it should not select just that Roadster. It should only select everything apart from Roadster. That's what this code here should do. So let me see. DFC2 just be DF underscore C. So I'll be selecting everything apart from the one where DF underscore C is equals to
Also, I
what?
think I'm creating a new data frame where we drop that particular.
Yeah, we can do that. I just want to like showcase this part of code. Like I just want to show you guys because this is an easier way to drop indexes. So I just want to show you. But if at the end of the day it doesn't work that way, I'll just sorry.
My interested is knowing this method too, sir.
Oh no, I'll just let me just try this. So if this doesn't work in the end, so we'll just use the normal stuff. So this is DFC. So I'm now going to say sorry, exactly. So DF underscore C, and we know that the top speed kilometer hour is equals to 410. Okay. So if this was as expected, oh, okay. I see. So I have to use DF. So the reason why that gave me an error is because I'm using DFC. And if you remember in DFC, I said that DFC should just give me only what? Model and efficiency. So I'm trying to look for the top speed kilometer column in a data set that does not have those columns. So that's why I'm having an error. So I think this should work. So you can see now that what this selected was what? Just that this selected just that model and the efficiency, just these two. So what I now want to do now is I want to say minus. So with this now I'm saying that give me everything apart from whatever says this is true. So if this works as expected, not working as expected though. Instead of it to drop just that one, it is dropping everything. Oh, I see. So that's the issue. Or let me get what df underscore c is. So DFC is still what I expect it to be here. So now let me just say that this is, let me see. Okay, she's working. So now should it be outside or inside? So I'm just trying to make sure that I use this column. It has been a long while I used it, but when I used to work a lot on this sort of stuff, it used to help me. But it is not working as I expected. So I'll just, sorry for wasting our time. No need for me to waste much of our time. So let me just remove just that column. So what I'm going to say is that um let me say DFC2 is equal to DFC dot um so I'm just going to say dot iLock. So I'm going to be using indexes. So I'll index everything up to index 50. Okay. So after selecting everything up to index 50, I'll now say df underscore c2 plus df underscore C dot iLock everything from 52. Okay, let me put 51 here. So let's see if this will work. So you see now that in this new one now, so what we are saying is that for these data sets 0, 1, 2, everything is getting up to index 50. So at index 51, we have a none. So we should not have a none here. Okay. Let me run this one first only. So if I run this only, so what I've been able to do is for this DFC2, I've been able to successfully select just 1 to 50. So what I now want to do is I want to concat. So pd.concat. When I'm concating, I'll now concat this new one that contains just 1 to 50. There are other simpler ways that you could have done this, but this is the one that comes to my mind off the top of my head right now. So I'll now come here and select again, but this time I'll be coming from what? I'll be coming from 51 downwards. 51 downwards. So if I do this, based on the results, first, okay, of a data frame. So this must, when you want to concat, the two things you want to concat must be in a list. So I'll put these two in a list and then I'll run this. So I can see now that we now have all of these data sets 0 to 1. So if I try to, let me just name this df3, df underscore c3. So if I run this now, so if I try to get on inside the df dot underscore c3, if I list all of the indexes, df underscore c3 dot index, you will see that this is not showing. Okay, let me list it. Dot index. Let me see dot to list. Does it have this method? Exactly. So you can see that when we get to 50 to 51, the 51 is still there though. I don't know why that's. I'm sorry. This should not be from 51. This should be from 52 because what I'm trying to drop is at index what is at index 51. If you remember correctly, if you remember correctly, what I'm trying to drop is at index 51. So I should have started from index 52. So I'll just start again from the beginning here. Let me just check. Is there anybody that is waiting to enter? Okay. So I've selected DFC2 that stops at 50. So now I'm going to be selecting this that comes from 52. And then I'm going to run this. So now if I run this dot index dot to list, so you see that from 50 we go immediately to 52 and we have already removed that outlier. So that took too much time than I expected, but that was what I just wanted to show. So what I'm just going to do now is that, so let me clear this. So this is DFC3. So I'm now going to rerun this code. So let me just copy everything so that we still have this from our one code. Let me paste it here. So I'm now going to just change this to df underscore c3. And this is also df underscore c3. Oh, I have to run this sorting. So I have to sort this data set again. I'm not the one that likes to be typing code. Once I've done it once, I'll just do it. So after getting this new data frame, so all I have to do now is to sort this data frame. So DFC3, and I'm going to sort it by the what? By the efficiency. Ascending is equals to false. So once I sort these data sets, and now that is what I'm using in this place. Now I'm going to plot it out. So on plotting it out, you can see that for this data set now, the EQV is still the highest, just as yesterday, each one, the EQV is still the highest. So what is now the issue? Why is Power BI telling us? Why is Power BI telling us that ESOL has the highest efficiency and Python is telling us that EQV has the highest efficiency? And the funny thing is that this ESOL doesn't even come up anywhere around here in this model. So this is the ISO 39 kilowatt hours, and this is what the efficiency is telling us.
So what if from the Power BI you import the data set again?
okay, and see if it will be different. But the thing is, for the Power BI, I understand that we removed. Okay, sorry, let me just check something. I'll do that, but let me just check this DFC3, and let me check if we have any DFC3. But that's the thing, this cannot work. Okay, I know what I'm going to do now. The one that is trying to like. So what I'm going to do is from this data set here. So this is the top speed. This was the 410 that we removed from the top speed. Accepted. So in this DFC, what I'm going to do is I'll not make DFC. I'll also include top speed in DFC. So let me copy this and paste this. Okay. So now let me check the DFC. So the DFC will now have this top speed also. So now I'm now going to say that for this DFC, okay. So I want to work with just DFC now. So DFC df underscore c, where the top speed is equals to 410. Okay, you can still see this. Or let me even use greater than or equals to. So you can see that this is working. So in this DFC now, what I'm now going to do is that I'm going to first say DFC2 is equals to DFC. I want to see if we're actually removing dot iloc up to what? 51. Okay. And now DFC3 is now equals to DFC DFC2 DFC dot iloc exactly 52. So since if this works as expected, so now I'm now going to run this code again now. Control V for DFC3. So if this gives me empty, it means that we have been able to successfully remove this 410 in this data set. So let me sort the values by ascending. Okay, let me change this to true so that the biggest ones will come up first. So now let me now plot this for DFC3. So according to this data set, the EQV 300 long is still having the highest efficiency. So what's the difference? So let's go back to Power BI. Okay, in Power BI, let me plot in, let me bring in a new data, let me bring in a data set. So this is 12 o'clock and our live coding session should end soon. But just for clarity purpose, so no need to save this. So let me go back, pick our data sets. Control A, Control C, Control V. So this is our original data set, yes. So now let us automatically create a report again. Okay, so since we have already creating a report again, let's just wait for this to come up. So that's why when we are making visualizations, we should ensure that whatever it is we are doing, we are sure that we are getting the correct value. So I'll just click on the edit, continue. I'll create a new page and then let me build a bar chart. So for this bar chart, what you want to check on the y-axis from the table is the model, and for the x-axis, what you want to check is the what? Is the efficiency. the sum of the efficiency. And you can see that even without this, the ESOL here is still showing us what 64 kilowatt hour for efficiency. And this is different from what Python was showing to us, the ESOL 64 for the efficiency. So let us go back to Python. Okay. And let us work, let us do some stuff. So let us say this is df. Let me confirm that df is still as I expected it to be. So let me say df, and the df for the model is equals to, so let's pick this. Let's go to Power BI. Let me just pick up the name of that stuff. ESO 64. Okay. Unfortunately, I was unable to copy that. ESEOUL. So okay, ESOUL. ESOUL. ESOUL 64 KWH. So let's see. So this is not showing up. It might be because I'm not getting the name. Maybe I'm not getting the name. So what I'm trying to do is I'm trying to come to Python. Let me get all of this model. Let me get this model, and then let me just manually sum up the efficiency. Let us see what we have, and let's see which one is giving us an error. Is it Power BI or Python? So ISO 64 kilo WH. So I don't know why I'm having. Okay, let me just go to the data set and try to look for it. Control F, ESOUL. So I've seen it. So let me just copy it. Control C. So here it is. Control V. What can I do differently? So you can see that these are the only two data sets here that are this clear, and two of them, they are not even in the. It does not have the top speed. The efficiency is not more than 400. So let us sum up the efficiency. So what's the efficiency here? The efficiency is just 175, 175. So let me just do this. Control C. Dot. Let me copy this efficiency here, and let me paste this dot sum. So this is 350, and let me do this again for the other one. The other one is EV long something something. So let me come here and get that name. That's EV. Let me go and get it from another place. Sorry, let me just type that in. LONG. But based on what I'm saying, I'm thinking it is Power BI that is wrong. Okay, exactly. See. So, and let me come here, Control V. So we can see the efficiency of this one is what? 273. The efficiency of this one is actually 350. So based on this, the sum of the efficiency here, this is 273. So actually Power BI is correct when it says, let's switch to Power BI. So Power BI is correct when it is saying that for this, it is around what 350, but for EQV, it is around what 200 and just a bit above 250. So Power BI is correct. So if Power BI is correct, then that means the error now comes up in the way I'm plotting this data. So now let me see.
Hello, sir. Remember
Yes, I
you're
can
saying
hear you.
sum of efficiency. That's the title. What if in this Power BI you change the sum of efficiency to maximum?
But let me I get. But you can see, for example, for example, when we come through this using this now, if we sum these two efficiency here for this ESOL, if we sum up these two efficiency, what are we having? We're having 350. Can you see that? But if we sum up this efficiency, let me just copy this. Control C and Control V. And if we run this, you can see that the efficiency here is 273. So that means the efficiency for eSol is actually higher than the efficiency for EQV. Now let us go to our Python visualization. Our Python visualization here is saying that EQV is the highest, which is wrong. It should be what? eSol that is having the highest with 300. Where's the ISO? Is this ISO 64 that should have the highest with 300? So if you go to Power BI, I've not been sharing the correct tab. This is the tab that I want to share. So if I run this code here, you can see that the efficiency for this ISO is what? 350. If I run this tab, the efficiency for this EQV long is what? 273. So if I go up a little and check the Python visualization, this Python visualization is now showing us that EQV long is higher. Meanwhile, what should be higher is what? eSol at 300. So there's an issue with this visualization. That means what Power BI is telling us is what? Is correct. Because Power BI is telling us that this eSol has what? Up to what? 350. You can see it is telling us 350. That's 175 plus 175. While EQV has just one and it is what? 270. 273. So Power BI is correct. The issue is coming from this what? This Python visualization. So just to confirm from this Python visualization, I will come here. So this is where we are sorting it, Abby. So we have sorted this out. Oh, let me just DSC2, DSC3. Okay. So now let me sort this again. So now let us go into DFC3 and let us see where the issue is coming from. DF underscore C3. So if this is correct, should have what? Efficiency of 104. Okay, let me make this false. I want us to see the top from top to bottom. We can see that there's still an issue. This one is saying that the EQV long has the highest with 273. Meanwhile, it should be the eSol 64 that should have the highest with 350. So that's where the issue is coming from. So let me come into this code here and see if there's any error with my code. But there's no error with the code, and this should be how it should be. So let me just check something. So let me check for this and let me look for this model. So once we are able to figure out what is causing this issue, that will be the end of the live coding session today. So if it is not an issue from us, it might be from issue from the guys that it might be an issue that we have to raise on their documentation and stuff, because I don't think it should be an issue. So let me go back here. If you have any question, you can stop me while I'm trying to figure this out. Exactly. So the model is equals to Control X. Yeah, is equals to Control V. And let me put this inside another stuff. And this df underscore c3. So now let's run this. So you can see here that in this code, this thing is not summing up. That's the issue we're having. The issue is that in this code that is being run, it is not summing up these efficiency values. Exactly. So that's the issue that I've been having. So what I'm doing is that in my code, yes, when I run this code, what I'm running is that I'm just running the maximum efficiency for each model. Meanwhile, Power BI is showing us the maximum efficiency for each model after they have been summed up together. I hope that is understandable. I think is it Ineka or Inena? Sorry for that. I'm not saying your name. That's why I'm making that mistake. I think it's Inena. Yes, you mentioned that earlier. That might be that one of them is showing for the max and the other is showing for the sum. So that's the issue. So now, what I have to do now is that for this DFC3, For this DST3, what I have to first do now is I have to sum the value. So DST3 dot what? Dot okay, where did I do the group by? Because I know that I need a, oh, I see, that's the issue. So I should have done a group by. After grouping by each model, then I'll now sum the what? The value of efficiency. So let me just do that here. So let me say, before I plot, let me do df underscore 3 dot what? Group by. So I'm going to group by what equals to model abi dot df underscore c3 dot group by model dot sum. What's the issue? Oh, okay. Dot efficiency. So let me exactly. I'm knowing that this should work as expected. So you can see now that for each of this model, it has been grouped and it has been summed. So just to confirm that what I'm doing here is correct, let me get the efficiency and let me get the max. So you can see now that the max efficiency we are seeing here now is 350. So if the max efficiency we are seeing here is 350, it should belong to the what? Dot ID max. Is it I or was even that index? Forgotten that something no. There's this method that shows the index of the max something. Okay, so but this is working as I expected. Dot sum. So let me call this df4. X Control V. Okay, so since this is df4, so let me come here. Oh, I forgot the C and change this to df4 and change this to df4. Then run this. So what's the issue? Dot key error model. Right, model should be there. df underscore 4. Oh. Oh, I see. Because of the new index, that is causing an issue. Okay, so what I'm going to do is I've seen the issue though. So I'm just going to sort this. So once I am able to get off this plot, then we are done with today's live coding session. So if we are going through it at any point in time, but at least we have been able to go through Power BI and I've been able to see that these visualizations, they all say the same thing. So any visualization tool you are using, they should all tell the same story. And when you remove outliers, you see that it changes the scale of whatever it is that you're working with. So the reason I'm even having an issue with this one is because this data set that I'm storing now, the index has taken the role of what model should be doing in this data set. So I'm just going to leave this for now. The group by model dot sum. Okay, let me come here to do this again. Dot ind index, sorry. So exactly. So the index is now the model. So let me just say, so okay. So this df4. So df4 dot reset index. Let me do this first and see what will happen. Exactly. So we're having a model now. And based on this model, dot drop. So let me just set this to df4. Now if I do this,
You're repeating therefore.
I'm repeating DF4 coming. So 350. But as you can see now, the highest, but just based on this, I will sort it. But you can see now that the highest efficiency here is now what? 350. And this highest efficiency that is 350, once we follow this bar down, it is going to what? ISO 64 kilowatt 100. So what I just have to do here now is, the reason why this DF4 was an issue is because I've changed it in this place. That's why. So now you can see that that stuff has gone. So what I just have to do now is to just say that DF4 is equals to DF4 dot sort values by so we are sorting the values by the what? By the efficiency. So you can see now. So if I plot this now, it should give us the, you see, nice and long. And you can see that the first thing that is coming up is the what? The ISO 64 kilowatt 100. And the next one is the what? The EQV 300 long. And if we change to the what? To the Tableau visualization, that is exactly what Tableau was telling us by telling us that the what? The highest efficiency is for the what? ISO 64 kilowatt 100 and the EQV 300 long. So you can see that this is the same visualization. But then again, we now have to come out in interpreting these visualizations, because if we bring it out now and say that okay, the highest efficiency in the data set is ISO, that's true when we sum it up. But for each particular car model, the EQV long car model for a single car has more efficiency than a what? Than an ISO 64 kilowatt hour car. I don't know if that makes sense, because the reason why the ISO model is getting up to 350 is why we summed up all the ISO model in the data set. But if we are just picking up the maximum efficiency for each model without summing them up, we just say, okay, for this model, what's the maximum efficiency you can get? For this model, what's the maximum efficiency you can get? Then this our other visualization here will be the correct one, where we are saying that what? The car that a single car can have the highest efficiency is the what? The UQV long 300. Does that make sense?
Yes, it makes sense. That's why I was
Yeah.
saying in Power BI, why don't we use the maximum instead
The
of the
max.
sum?
Yes, exactly. So that's what you were trying to say the last time. Thank you for that. So I think with that we have come to the end of today's live coding session. So just to share this tab and just to showcase what we're saying. So if we just come here to
So I
this
complete the 2 questions remaining now.
with this stuff should be for 1 hour. We are going to 1 hour 30 minutes already. But I don't think there's any other live coding session today, so we can just do that.
Exactly. That's why you should try to finish that 2 questions.
All right, so just to showcase this instead of sum for efficiency, let's change this to maximum. And if we change this to maximum, you can see now that this EQV long 300 is each one, blah blah blah. And if we go back to Python and share this tab for our other one, you can see that this is EQV log E300 each one, blah blah blah. So I think that is sorted out. Okay, so just to indulge you guys and just to answer these 2 questions, and then that will be all for today. So the first thing that what question was that? Let me just go and copy them. So I think it's these two. Control C. So what manufacturer has the most number of vehicles? I think we have done that safe. Let me just paste this. So what manufacturer has the most number of vehicles? What's happening? You should not. Exactly. So what manufacturer? So we just get our DF, and for the manufacturer, what are they known as? They are the brands. So what we just have to do is that for each brand, we'll just sum each brand. The easiest way to do that is to use the count plot from Seaborn. SNS.count plot. Okay. And we're going to be counting the what? X is equal to what? The brand. Let me make this capital letter B. And then the data we are using is what? Is DF. And let's plot this out. So you can see that this count plot, but as expected, all of this is having what? Different names. So let's just increase the figure a little. PLT. Okay, let me just go over to YouTube and check if there's any. Okay, there's no question on YouTube. All right, so let me continue. So PLT dot figure, the fixed size is equals to 10 by 10. So increasing the figure size, it is still what? It is still a bit. So what do you have to do? You need to change the rotation. PLT dot x sticks. Then rotation is equal to what? 90. When we do this now, you see now that okay. So based on this data set, we can see that the brand with the highest number of cars in this data set is what? Is Tesla, coming at number 1 with more than 12 cars. That's around 14 cars. Then the next brand is what? Volkswagen. Then coming next is the, so if you want this, we can sort this out also. But just with the count plots, we have been able to identify that okay, the brand that has the highest number is what? Is Tesla. That's for question 2.
Without
So
visualizing it, you can't wait for a code to reveal it without visualization.
without visualization, yes, definitely. So if you just want to, without visualization, you just say for this data set, you just use group by. So you group it by the what? By the brand. BRAND. After okay, I missed my B. So by the brand. So after grouping it by the brand, instead of using sum, you use count. So when you do this, what this will do is it will go through the brand. Oh, okay. So this is every brand, and it is going to be counting. Okay, no. Dot counts. Dot sum. Coming. I'm trying to see if that will work. That does not work. Then this is another method. But okay. So I want to select just the brand. BRAND dot count. Exactly. So as you can see, so what we first did was we grouped it by the brand. So after grouping it by the brand, we now selected just the brand from the data set and counted each brand. So you can see that the highest brand is 1, Audi has 9. So if we look for Tesla here, the Tesla has 13 brands. Sorry, the Tesla brand has 13 what? Occurrences in this data set. Then the next one is the Volkswagen. So this is this doing it without a visualization. So group by is a very, very extensive, is one of the most powerful things that Pandas has given to us. So once you're able to use the group by function, okay, once you are okay with the group by function, then you are very, very good. You'll be able to do a lot of stuff and be able to get so many stuff when you are using the group by. So this is we getting the brand with the highest number of cars without even using visual data. So the next one is, how does price relate to rapid charging? Okay, so let me see what is the rapid charging. Let me see what kind of column it is. Rapid charging, brand, top speed, fast charge, abi? Okay, this is rapid charge. So rapid charge is what? Is categorical. If I come here, rapid charge is what? Is categorical in nature. It has just either yes or no. So we want to do a visualization that shows the difference between, that shows if price has a direct correlation with if there will be rapid charge. So one of the ways that we can do that is we can use a plot that shows the yield. So let me just try something first. So this SNS.scatter plots. Okay, so what's the column for price again, Seth? Price euro. So scatter plots. So we're going to make x is going to be equals to the price. So we're not going to say that the u. So the u is now going to be the what? The rapid charge. Forgetting all of this spelling. Okay, Control C. So let me pick this here. And this is rapid charge. Control V. Rapid charge. So if this was as expected, could not interpret price euro. Oh, sorry, I did not provide data. Data is equals to df. Not scatter plots. Okay. Oh, there's a space here. There should not be a space here. So this is not happening as I expected. So this is, let me remove all of this first and see if this will. So what I want us to do is I want to plot. So exactly. So this is why. So if this is, so what I'll just do is let me do mp dot range, or let me say, let me make this one y. Now let me make x. You remember yesterday I did something like this, mp dot range df dot shape. So when we want to do things like scatter plots, so this is like a univariate where we know that it's just different numbers. So we don't want to know, we just need a placeholder for the x values. So for each value of x, then there'll be a plot for the price euro for each of the data sets. So let us do this first. So this is normal range to pull objects. Oh, sorry.
Imported, we're not imported NumPy.
I know NumPy is important. I'm not even using NumPy anymore. I'm just using the normal range. So this is the price euro. So this is like for the first car in the data set, this is the price. For the second car, this is the price. For some other cars that are around this range, these are their prices. So this is just a scatter plot where once it goes for each index of each car, you get for each index, like when we are going, what I'm trying to say is that for each row now, so for row 0, it will just plot the price at a particular point. For 1, it will plot the price. For 2, it will just pick a point that is that price. That's what this scatter plot here is doing. So what I will now do now is I will now add a hue. There's something called hue. So hue is like color. So I'll now say color this data set based on a category. So the category that we want to use here is now going to be the rapid charge category. So when I run this now, you will now see that you can see that for the rapid charge, there are no, but for rapid charge values, what are you saying about the price? The price is the y-axis. The rapid charge, cars that cannot be rapidly charged, they are what? They are only low. Those are the ones that are what? Yellow. You can see. So this yellow point now is a low price. So as long as a car is what? Is not rapid, is not able to be rapidly charged, that car will not have a higher price. So there's an issue because our data set is for this particular column, the data set is biased or is imbalanced. That's the word. We have more.
Can you come again with your inference?
Yes, the inference. What I'm trying to say is that for every car, as long as a car cannot, that that's no. If the car cannot be rapidly charged, the price of the car will be low based on this data. You can see that this is a car that cannot be rapidly charged. This point, what's the price? The price is around 25. This is a car that cannot be rapidly charged. What's the price? The price is less than 50,000. This is a car that cannot be rapidly charged. What's the price? The price is around lesser than 25,000. This is also lesser. This is also lesser. There is no car that cannot be rapidly charged that passes this 50,000 mark. So based on this visualization of this data set, that means as long as that car does not have a rapid charge feature, that car will be lesser in price compared to other cars that have a rapid charge feature. Is that understandable?
Yes, sir. So
Yes,
this is like
but
more like dimensional graph in a way.
Sorry?
Initially, I was thinking the horizontal, this is a scaling of 0 to 100. I was thinking it's a count actually. It's not absolute. It's a count. So looking at 80, 100,
Oh,
low
okay,
price.
yes, it's a count. This does not have any relationship with whatever we are doing. You get? It's absolute. So, but it's because it will not be, because if we start plotting out the counts for, because instead of this to be 0 to 100, this should actually be each car, and each, you get, this should be like, okay, let's say a Tesla 100, this is the price. A Mercedes something, this is the price. But if we try to put that on this scale, this visualization will not come out as it is. So that's why we're just using 0 to 100 as just a random scale to just show that there are 100 cars. You get, there are 100 different 100 different data points, but these are the prices that are.
Frequency, number of occurrence. Am I right, sir?
Yes, exactly. Number of occurrence. So
Thank you, sir.
as I was saying, so you can see that for this, what we're actually concerned about is this horizontal scale. And you can see that for prices of any data points that happens that for that data point, the car cannot be rapidly charged. The data points will not be what? Above 50,000. So it is an imbalanced data. Why? Because most cars can be rapidly charged. So it is very imbalanced. So if it was to be balanced, then we would have been able to see more of this distinction. But because based on the data, based on the points that are existing in the data sets, this is what we have. So that's the inference that we can have based on these data sets. So those are the last two questions. So just to recap on everything, most of everything that I've been doing, all of these pie charts here, they are univariate analysis. Univariate analysis means that you're working with just one column. Those are what this pie chart is. So this here also is a univariate analysis. Why? Because we are only dealing with what? One column. But this is also a univariate analysis. Why? Because we only deal with one column, which is the brand. But this analysis that we did there, these are our first bivariate analysis. What's the meaning of bivariate? We are working with two columns in that same data set. So we are working based on the what? The price, and we're also working on the what? We're also working on the what? The rapid charge. So those are two column data sets. So univariate will just deal with analysis that can be seen just from one column only. So when we start seeing different, I think this is also a bivariate. Sorry, this is a bivariate because we are working with the powertrain and the efficiency. So we're looking at how the powertrain calculates, how the powertrain relates with the what? The efficiency. So, but all of these here, these bar charts that are just single, they are what? They are univariate in nature. So another type of popular bivariate, I think I mentioned that I wanted to do something there, was, okay, so I've done that already, using count plot and using U. So using U is one of the very popular way. For example, let's say we come here now on this data set. On this data set now, we say that we want to do SNS dot count plots. Okay, dot count plot for each model now. So let's say the X, what's the category? Let us use something like, what category? Let's use the seats, for example. The seats. Okay, so for the seats, let us now say the U is going to be equal to the what? Rapid charge. Okay, so let us say the data is equal to DF. So if this was as expected, okay, is it not seat? I thought it was SCAT. Let me check the column names again. Okay, there's S seats. Seats. Okay, I think C is also capital letter. So you can see now, this is we doing a what, and this is what I was trying to say that we could not do in the Power BI, where two categories were lumped up together. So you can see that for two-seater vehicle, we have 0 what? Rapidly charged vehicles. But for the two-seater vehicle, non-rapid charge, that's no. is more. For four-seater vehicle, most of the vehicles that are four-seaters, what happens to them? They can be rapidly charged. Majority of the vehicles that are five-seater can be what? Rapidly charged. But once you get from above five-seater, based on this data set, you cannot have a rapid charge feature based on this visualization that I've just done. So this is a bivariate visualization that is showing a relationship between two categorical plots. Sorry,
What you're saying.
you did not hear what I said?
Can I ask a question, sir?
Oh, okay. I can. Yeah, you can.
Yeah, I have two questions, sir. Let me start with the second one. In this very last plot that we had, what if
Which one is that? Is it
no, where we were before? Where we were before?
this one?
Yes, sir. Now, having deducted before now, based on the scatter plots, that
Okay.
cars that have higher number of that will not be rapidly charged are cheaper in prices. Now,
Okay.
since that is true, coming back to this place, seeing that
Okay.
we have a higher number of rapid charge, many of them, I'm trying to contrast. That way, we can also contrast this with the what's the question again? It's trying to escape me now.
Is there a way, yeah, to bring both of them? That's the scatter plot for the price and then the number of seats to see if the price also has a correlation with the number of seats based on if they can be rapidly charged or not.
And my second question, sir, is on the scatter plot. It is easier for us to visualize in the scatter plot because there are two unique values in the categorical. That's the rapid charge. Yes or no?
Yes. Yes.
We have more unique values.
If you have more unique values, you just have to increase the size of your data, so the size of your plots. But yes, because the number of categories we have are lesser, that's why it is easier to visualize. If there were more, you would have had to like probably increase the size of the plot to accommodate all of them, or probably look for another way to visualize it. When you have much more like that, it's easier to visualize when it is horizontal. So you will change the orientation and make the orientation horizontal. But I've forgotten how to do that. I think there should be something orient.
I know it. I know it.
Sorry?
I know what you're saying.
Oh, okay, exactly. So
the first
I don't
question,
think okay,
correlation
but you, sorry?
first question, sir. The correlation between
Okay, yes. So for that, what we can just do is we can just try to do a correlation plot of this same thing and now look at it with the number of seats. So if we come here, and do this. So instead of rapid charge, what will now be here is the seats. Okay, so if these are the seats, so we can now see, but this because of there are ways to use better colors. But based on the better colors, the first thing we'll now be able to check is if based on this, we know that there's like a positive correlation between seats and rapidly charged. What do you mean by is it positive or negative now? But the higher you go in the number of seats, the lesser it is to be able to do what? The lesser chances you have to be a rapidly charged vehicle. So when the number of seats are very small, which is 2, there is no rapid charge. When the number of seats get higher, 4, we can say that okay, there's rapid charge, but we can say that the number of rapid charge is reducing because immediately the number of seats gets to 5, the number of rapidly charged vehicles are drastic. So we can say that okay, there's a negative correlation between the number of seats and the rapidly charged feature. So once we can now do is we can now check the correlation between price and the number of seats. So when we check the correlation between price and the number of seats, we'll now be able to we'll now impose that on the correlation that we have between the rapidly charged and stuff. So based on this now, since we have said that from here, if you cannot be rapidly charged, what will happen? you will be what? Lesser in price. So therefore, with this now, we can say that all of these that cannot be rapidly charged, they are lesser in price. So we can say that, okay, cars that have 7 seaters will be definitely be higher in price than cars that have 2 seats. We can also say that cars that have 5 seats will also be higher in price than cars that have what? 4 seats. And just like I said, because these data points are too small compared to the scale of the data set, it might not be tangible to give a correlation to other to other variables based on this. So a better category to base why prices, because the number of seats has tendency to influence the price more than being rapidly charged can. Why? Because the number of data points for rapidly charged are just few compared to that of the ones that can be rapidly charged. So we can use the number of seats as our reference point and say that it is even because the number of seats, as the number of seats increases, the price increase. So we can say that that is what is also making the fact that if you cannot be rapidly charged, since the fact that you cannot be rapidly charged is attached to the fact that you have lower number of seats. So it is better to use the number of seats as a reference point than it would be to use the rapid charge feature, because that data point is imbalanced.
I understand.
I don't know if that was understandable.
So that means that in making prediction, we can drop that column.
Yeah,
And
definitely. You can drop that. Yes, definitely. You can. Or when guys, the data science guys, there are methods to balance and imbalance data. If a data set is imbalanced, there are techniques. One of them is SMOT, smooth. That's the most popular. So it's smooth to be able to use random probability to balance the data set. So when both of them are balanced, then you can use that for prediction. But it is not advised to do that when you are visualizing. If you are visualizing, just work with the original data that you have. Show the picture as it is. But when you're now going to machine learning and working on some things, then you can have some other aspects. You can start introducing all of those techniques in there. So is that okay?
yes, I'm fine. Thank you very much, sir.
Yeah, all right, no problem. So with that, we have come to the end of today's live coding session. So that will be the last live coding session for this stage. I don't think for the data science track there's no
I have a
um
question for our quiz, sir. There's a
okay.
reference, the comment that there will be no tag along code in this stage
Yes, there will
for
be no tag along code for
what's
data
the
for data storytelling
are we
track.
expecting? Are we going to be writing technical writing a report, or I'm just trying to
No, there will be no. So after this course, you're not submitting anything. It's until the next stage before you have a tag
I
along
mean
that you submit.
quiz. What are we expecting? Since there's no code, are we going to answer
Since
questions with Power BI
yeah,
or
for the quiz, you'll be answering questions based on the course content, and there'll probably be some visualization. As I said, this is my first time working with the data storytelling track, so I don't actually know what's the content of your quiz actually. So I don't know. Maybe I can probably try and drop something on the track to give you something you expect. But since there's no tag along, then it will most likely be on those questions based on the course materials for the quiz.
Hello, sir.
Yes, I can hear you.
Okay. Please, based on this telling, when are we at storytelling?
When
Or this what we are doing? When are we going to dwell on more on the storytelling? Because that's
on this
the technical part of it.
the technical part, in what sense? Is it like getting inference or
Based on this stage course outline, like the lessons, like what is the technical writing and planning your documents and all that.
and all of those?
Is there no practical part on it?
Is it based on this stage? That
Yes,
was the
based on
first
this
part, the
stage.
part of technical writing. That
Yes,
one
based
that
on
is
this stage.
I don't these are the two live coding sessions that we have, yes. And based on the content of the course, I was like, okay, based on these two stuff, what is more likely for people to not grasp? I don't know if you get what I'm trying to say. Like, what is more likely for people to have an issue with? So the technical part of setting up a document, working with Microsoft Word or whatever documentation tool you want to use, and all of those stuff. When I was going through it, I was like, okay, these are something that the course content can do justice to and can be easily understandable. I don't know, but that's how I felt. So I was like, it would be better to showcase all of these because there's nothing to write if you don't have anything to showcase. There's nothing to showcase in the first place. So that's why the live coding session focused on all of this coding part and some of those stuff. But if you feel that what is the course content are not enough to be able to showcase some of the technical writing aspect that you need, then I'll look for more content and materials that will paste on the group that you can use to learn further. But for the live coding sessions, I just decided to focus on this aspect where I know that it might be harder for people to grasp or something like that.
All right. Thank you, sir.
Yeah, no problem. Okay, so with that, if there's no more question, thank you. Of course, we spent quite a large number of time, but it was a nice session. So you guys, I wish you all the best in your courses. So if you have any question, as usual, just post it on the channel. Immediately I see it out and tag the coordinator, and immediately I see it, I'll be on hand to answer those questions. So you guys have a wonderful day, and bye bye for now.
Thank you very much, sir.